What I wanted to talk to you about today is what new I plan to do for paper. But if you will indulge me, I would like to put my new plans and new efforts in a historical context. So first of all, if we would look backward, yes. What do we have here? This is a page from a notebook from a person who did a truly great work. I'm sure we all agree. This is from Isaac Newton's notebook. And you see from this, if you look carefully at this, you don't need to read the text. But if you look at this, you can see that Mr. Newton had a problem, actually. And the problem is shown that he is writing off the margins and he is squishing his text up because he didn't have enough paper. And in fact, if you read his personal journals, you will see that he was a cheap guy, but you will see that he was obsessed with the amount of paper he had. He kept track of every sheet of paper, how big, what kind of paper it was. So this was a problem. In fact, if we go back even further, Tycho, the Danish astronomer, he built his own paper mill in a true example of vertical integration to solve the problem. So the problem that Professor Newton had was finally solved by this gentleman, Louis Robert, circa 1800, who invented something that we call the continuous paper machine, otherwise known as reel-to-reel or roll-to-roll manufacture, right? The raw materials come in one end, and the paper goes out the other end, and in today's environment, it operates 24/7, 364, maybe a day off for Christmas, all the time. And I think that when Mr. Robert invented this, he could not have conceived the power of the manufacturing platform that he had launched, that in today's environment, if we look at the newest installation at Sun Paper, produces 1 million tons a year of material, of packaging paper, a material that is functional, that is renewable, that is recyclable, and that is profitable. Let's take a look, if you will, a little bit closer at how the development actually happens. The consumer, of course, defines what he needs. In our example here, it's Isaac Newton telling that he needs a substrate to record his ideas for posterity and to scribble out his calculus that he was developing and so on. And we use the raw materials that are available to develop this. This is our technology platform underneath, and the machine platform, the machine technology that is available. And people being people, we want more of it, we want it cheaper, we want it faster, right? So we have to develop these things all the time to meet that ends. Products differentiate over time, so products become product categories. Every once in a while, a really clever person comes along and he comes up with a product idea that can fit into this platform that is now developing. And so we launch a new product, becoming again a product category. Now the conventional wisdom says that this is dead. This is stagnated. All the meaningful development in the bioeconomy is going to come elsewhere. And this one is stagnant. But this is patently false. Actually, the thing that's happening is that the first and oldest category of papers, the communication papers, is in secular decline. This means that it is being supplanted by electronic media, right? And in order to backfill the capacity that we lose from the communication papers with those grades that are still stable and growing, it takes decades, actually, decades. This is something that's very difficult for policymakers to grapple with, particularly as it causes a lot of pain on a local level. But in the time scale that we're dealing with, it's just a blip, actually. It's just a blip. The power of reel-to-reel, roll-to-roll manufacturing is still as valid today as it was when Mr. Robert invented it 200 years ago. So you see a question mark there. What new product am I coming to offer you? And the answer is nothing. Nothing. Don't listen to me. Listen instead to that guy on the screen, that little guy on the screen who is looking out at you. What is he saying? He's saying, don't take my home. Don't poison my food. Don't poison my water. Leave something for me. Do more with less. So the issues of sustainability transect all the product categories, which intersects with other value chains and other aspects of society. I would like to take a look at one particularly malicious aspect of sustainability that impacts all of our lives. Here I am enjoying myself when I'm not making research in the ocean, and whether I'm in the South Atlantic or in the Barents Sea, I see the same thing. And that's not a plethora of giant fish, it's a plethora of plastic. We have created a material that we perceived as being beneficial to mankind without considering its implications. It's now in the deepest depths of the ocean and the upper reaches of the atmosphere. It's in you, in me. It's in all of us. It is for our generation. It is for our children. It is for their children. It is forever. That is what we have done because we have not considered the sustainability of what we are doing. We have to correct that one. Plastic, we produce in the world about 400 million tons of plastic. And we produce, very fortunately, about 400 million tons of paper, roughly. Already today, these categories go head-to-head in competition across a number of product categories. So everything that we do to improve the competitive position of paper improves that side of the ledger. But if we really want to make headway, then we have to recognize that plastic and paper, those are, they're different kind of materials. They're fundamentally different. If we want to make paper more like plastic, right, it's not development as usual that Mr. Robert would recognize. We have to start going deep into the structure and try to make cellulose do things that it really doesn't want to do. So how do we do that? Well, here's how I've been doing it, right? Micrograph of paper. Paper is composed of fibers. They look relatively big in the micrograph. The fibers are composed of fibrils. So in principle, we can decompose our fibers into fibrils and, with a lot of clever engineering, make something that reminds of paper of that one. So we're building our material now from smaller building blocks, in principle giving us higher functionality. And indeed, this kind of nanopaper had higher functionality in some respects. Companies were involved with this kind of research. They feed off this. They have taken this into their own product development. This is going on in paper companies. I even took this so far that I built a machine, actually, here at Aalto University to, show that this can be done in a reel-to-reel operation. And it can. Now, the question that I ask is this is the wonderful thing about tenure, right? This is the time where I can ask, what am I doing? What should I be doing? What do I want to do? Am I doing my job? Am I doing the right thing? That is the question. Let us take a look at another example. I see my student Hamid sitting here. So he has done this work. Another example of a nanopaper. Here we take nanocellulose and we put it on top of a normal paper substrate. Nanocellulose is dense. It is, to a certain extent, impermeable to oxygen, right? So it is good in packaging applications, and it can, in principle, replace the polyethylene that we currently use for the oxygen barrier. So polyethylene out, cellulose in, again, good. Am I doing my job? Is this the right thing? Is this the right way to apply nanotechnology to the paper industry? We've been doing this, not just me, I'm not the only guy doing this, it's going on all over the world, right? We've been doing this now for about 20 years, long time. And I think at this point, you can read the questions on the screen. And the answer to these questions, it better be a resounding yes. We need to be able to produce our raw material efficiently. We need to be able to produce some products from that raw material that we can't really produce today, that we don't have some other way to produce. And we need to be able to do that at scale. And if I critically ask these questions, the answer for me is sort of, maybe, possibly, let's discuss. The issue, as I see it, is that when we produce the nanocellulose, we produce a material that is 3 orders of magnitude smaller. It is fundamentally different than the paper fibers. So to try to put that into the asset class, into the infrastructure that Mr. Robert has made for fibers, right, is very, very difficult. I can do it with a lot of engineering, but it is literally like putting the square peg into the round hole. Give me a big enough hammer and I'll hit it in. But is that the right way to apply nanotechnology to paper? Are we doing the right thing? And to answer that question, right, I would like to return to this one, the paper fiber. Beautiful picture of the paper fiber. You're all looking at the wrong part of the image. Down there, the legend. Done at Aalto University Nano Microscopy Center. 20 plus years ago, we didn't have this. In the 20 years that we have been working on nanotechnology, we have made tremendous investment in analytics, in people, in knowledge. It's so much more difficult to work at the nanoscale. I have had to update all the analytical methods I use, but a lot of effort in on that. So we have built a technology platform, a technology hammer that we can use in any way that we want. Now let's look at the fiber. It's a beautiful thing also. It's not, the pulp fiber, it's not a normal raw material. It's like a magical raw material. In the dry state, it is solid. And when you put it in water, it forms a hierarchical structure. The water modulates a hierarchical structure. Big parts built from little parts, built from smaller parts, controlled by the water. Can we leverage that? Let me show you that using some of the wonderful tools at Aalto. We have to look at it in the wet state, sort of simulate that. Same fiber, zooming in, right? This is how things look in the wet state. In the dry state, this would be solid. And you see that the fiber is controlled of fibrils, and it has a certain structure. Nature has built a beautiful thing for us, actually. The nanocellulose is organized already into a beautiful package. So shall we take our nanocellulose out of this one at considerable energy and expense and try to put it into the production system that Mr. Robert has created, or shall we take our nanotechnology and put it into this one? And that's what I say. So I am not saying that everything that we have done in nanotechnology so far is bad. It is one avenue of development. But I'm saying that we should open a second front where we don't take the nanocellulose out of the fiber and put it into the paper process. We take the nanotechnology and we put it into the fiber. And we do our nanoengineering on the fiber level. Now with this picture, I'm really getting wonky, right? I mean, you guys are, oh, what is this? This is my conception of the hierarchical structure of fibers. Cellulose organizes into fibrils. Fibrils like the aggregates into fibril aggregates. They like to form lamellae. They stack up. They form the cell wall. They form the fiber, and so on. And what I'm talking about, what I do, and I don't go into details here, is I'm controlling the fiber-water interaction across the different hierarchical structure, swelling the components individually and independently of one another. Wow, that sounds great. Let's imagine now that we have a process engineer that came here from Äänekoski, from Kotka, from Rauma. By the way, all places where I have worked, nice towns. And he comes here, and because he has graduated from Aalto University and he's taken Thaddeus Maloney's course in paper technology, he knows that fiber swelling is super important for the paper properties. So he's excited about this new way to swell up the fibers. And he says, Professor Maloney, okay, tell me how I do it. What can I do back in my mill? And I have to answer him, well, You have one tool to swell the fibers. And it is the same tool that Mr. Robert had 200 years ago. It's smaller, it's more efficient, it's more beautiful. It's called the pulp refiner, but it does the same thing. And it swells the fiber only in the crudest way, not touching the lower levels of structural hierarchy at all. We have studied this a lot. So I would have to say to this process engineer, you cannot do it today. But what you can do is you can come over to Aalto University, to our fine laboratories that we have invested in. You can bring your raw material with you. I have identified technology platforms for doing this type of modification. You can do that. We can measure the effect. We can put it into laboratory scale products. I can show you the benefits of that. And you find it interesting and we be successful with that. For example, the area I'm working in is lightweight materials, doing more with less low density structures. So you find this interesting, then we can work with you to bring that into the paper mill, and we can do the thing that Aalto University does that is so important. We can supply you with young, smart process engineers who are able to take the technology forward in your own businesses. So, with that, I would just conclude with these questions. This is what I've been basically doing during the pandemic, planning the thing that I'm going to do next, and this is what I'm going to do next. A lot of effort on developing the measurement technology. It's never good enough. I'm always asking Monica or whoever for new instruments and so on, but basically we have developed a lot in that area. We have certain platforms, chemical platforms we can use to modify the fibers in the way I want. We have demonstrated value-added, very interesting structures from that. We have a long, long way to go until we can bring this into the paper mill, where finally it will be validated if it is valid. So with that, thank you once again.